Okay, question number 4, part A. It is given that Z1 is equal to R1 e to the I theta 1 and Z2 is equal to R2 e to the I theta 2. We need to show that Z1 times Z2 and the conjugate of that is going to be equal to the conjugate of Z1 times the conjugate of Z2. So the way we do this is by taking each of these complex numbers and multiply by each one of them. So R1 e to the I theta 1 times R2 e to the I theta 2 is R1 R2 e to the I theta 1, okay, times e to the I theta 2. So we can apply the law of indices over here and we get e to the I theta. So I is common, and inside I'm going to get theta 1 plus theta 2. And if I have to take the conjugate of Z1 times Z2, so the conjugate of that is going to be R1, R2, right, into e to the minus I into theta 1 plus theta 2. And then on the other, and this is actually the left hand side, okay, and for the right hand side, I have Z1, the conjugate of that, times Z2, the conjugate of Z2. So let's take the conjugate of Z1, which is then, we're going to take the R as well. So R1 e to the minus I, theta 1, okay, times then R2 e to the minus I theta 2. So if we simplify this, we get R1, R2 e to the minus I is common, and then inside I've got theta 1 plus theta 2, and so that's going to be the second part here. So the right hand side is equal to the left hand side. These two expressions are the same. So since left hand side equals to right hand side, therefore we can conclude that Z1 times Z2 conjugate is equal to Z1 conjugate times Z2 conjugate. So we're going to move on to the second part of the question now. Second part, we have Z is equal to 3e to the 1/4 pi I is the root of that quadratic equation over here. Z squared plus bz plus c is equal to 0, where b and c are real. We need to state the other root. Stating the other root, let's call it Z1. So that's going to be then 3e to the minus 1/4 pi I. So that's my other root. So this is done. And now hence find the values of b and c. We look at this, we have a quadratic equation of b plus z z squared plus bz plus c is equal to 0. We must remember that this is the product of the roots. And here we have b as the sum of the roots. So let's deal with the sum first. When we talk about the sum, we understand that we should be taking z, let's say z, okay, plus, z naught plus z1, and that should give us negative b. Okay, and so we have z1, which is then 3, and then e to the 1/4, okay, pi I plus 3 e to the negative 1/4 pi I. So the 3 and 3 is common. So what we have then is e to the pi I plus c. So this is actually z, okay, plus the conjugate of z. And so what we're saying, this is z, okay, plus 1 over z. And if we do so now, remember this is z plus 1 over z is actually 2 cos of theta. Now in our expression here we have theta as pi upon 4. So cos of pi upon 4 is equal to actually root of 2 over 2. So what we're saying is then 3 times 2 is 6. 6 times the root of 2 over 2, and if we do so, we're going to get 3 root of 2. And because this whole thing is minus b, so then we have b as -3 root of 2. Now that's the value of b. And as for the value of c, so we've got more space over here now. So now for the value of c, that's the product of the root. So I'm going to say z times 1 over z, which is 3 times 3 is 9, and then we have e to the, add the powers here by law of indices, so this is going to become e to the power 0. So we know that e power 0 is 1, so I have then c as 9 times 1, so the value of c is going to be equal to 9. So here we are, take care.